All right, so this is often called the retirement problem because we have two types of cash flows. One is we're investing, so we're investing in something, and the second cash flow is that we are taking money out. And so we're going to introduce something called an annuity due. Up to this point, we've only had regular annuities, which have payments at the end of the period. And here, for a retirement problem, we need to have an annuity due. So first, let's read the question. Assume an investor contributes $6,000 per year in a Roth IRA at the age of 25 years old and earns 7% on this investment. At the age of 60, the investor plans to retire and live off this investment until the age of 90 years old. If the investor earns 5% in retirement, how much yearly income will this investment provide? So what we have to do is we have to go use our timeline. So at this point, you should be well practiced in using a timeline, and this question is extremely important to use a timeline. So let's go ahead and start writing out what we're given. So we have and the thing that makes this question usually a little more challenging is there's two parts to it. So the first part's the accumulation stage, and the second part's the distribution stage. And so let's go ahead and say what we have now. So we actually don't have any money starting out. So we actually have present value of 0. So we assume the investor contributes $6,000 per year. So we have a cash flow of $6,000. I won't write out every one of them, but we have 6,000 cash flows. And how many cash flows? Well, from the age of 25 to 60, that is, whoops, what happened? Cut out. From the age of 25 to 60, that's 35 years. So n equals 35, and our return is how much? It's 7%. So here we have a pretty simple, the first part of the question is this pretty simple future value, because we want to know how much are we going to have in our retirement account when we turn 60. So we have all our information. We can then go to our financial calculator, because we have our n of 35, we have a rate of 7%. We have a present value of 0. We have a payment 6,000. And we're looking for future value. And so when we're investing, typically we're putting money in at the end of the period. So we're going to assume that this is a normal annuity when we are putting money in. So let's go to our financial calculator, and our financial calculator is here. Let's see if we can have it large. Yep. All right. So the first part of the question is we have how many years? Well, it's for 35 years. 35n. Our rate is 7%. We don't start with any money in our account. We invest $6,000 a year, and we need to remember the sign convention. So it's $6,000 negative, and then we compute future value. So the future value of that $6,000 invested for 35 years at 7% is $829,421, and 27 cents. But we don't. So future value equals 829,421.27. So this number is now this amount. That is our future value. So now this is how much money we have in our accounts, and we need this money to fund our retirement until we're 90. So now our future value is at 90 years old, and this is at 60 years old. So our new n, and so now we're trying to figure out the payment, but our n in this case is 30. And our rate because we're retired, we maybe take a little bit less risk. Maybe we only get 5% return. Our present value is now this amount. Let me erase that. This is our present value. And our future value, so we actually don't really, at 90 years old, we're going to deplete this retirement account. Our future value is 0. But when you're needing money to live on, do you need the money at the end of the year or at the start of the year? Well, you're going to need the money at the start of the year. So you actually need the money at the first day of each year. We're going to assume that you take the money out on the first day. So what that's called an annuity due. A cash flow that happens at the start of the time period is called an annuity due. And we have to do a little adjustment to our calculator. Make sure you understand how to change this. And so what we're going to change is the standard setting is to be at end, and we need to change it to the beginning. And we'll show you how to do this in a second. But here we have all our knowns. Future value 0, present value 829, 421.27, our rate 5%, and our number of periods is 30. So let's go back to our financial calculator. And so we actually want to keep that number because the decimal places go out for very long. And so now this is our present value. So we can hit negative present value. Now how many years are we going to be retired? We're going to be retired 30 years. And what is our rate of return in retirement? Well, it's 5%. And our future value is 0. But what we have to do is now change our payment time to the beginning of the time period. And we do that by hitting second, payment, second, set. And so now we have beginning. So now this is assuming that the payments or distributions happen at the beginning of the period. And so we want to do compute payment. And our payments are going to be $51,385.76. So payment equals 385.76. Whoops. All right, so that's called our typically called the annuity problem, and so the thing, or the retirement problem, the thing you really have to be careful about is after you do one of these, so your payment is now, we can see that it's beginning, so we have to change it back, and we change this back by doing the same way we changed it. So you go second, payment, second, set, and now it's back to end. And so now we're assuming that the payments happen at the end of the period, and we can actually compute. So if we take our money out at the end of the year, it's going to be a little bit higher. So if we wait until the end of the year to take our money out, we actually can take out $53,955. But typically, the retirement problem, you put the money in at the end of the year, and you take it out at the beginning of the year. So that's a good example of our retirement problem. It takes a little bit of time, and you have to make sure you get the payments and annuity due correct.